Hello everyone, this is Aftab and we are uploading these videos as part of the online teaching learning process amid the coronavirus outbreak. This is the first video in this lecture series. After every 2 videos, you will get an assignment which you have to submit in the prescribed time frame. Hope that you will benefit out of this. Without much elaboration, let's jump straight into today's topic. And today's topic is the reciprocating pump. Let's get started. In this video, we are gonna looking at the main parts of a reciprocating pump and its working. I'll try to explain the stuff in a beginner's perspective so that everybody should be able to follow it quite comfortably. Okay? What we see on the screen is a single acting reciprocating pump which consists of a piston moving forward and backward inside a cylinder. A crank and slider mechanism with an electric motor is used to achieve this to and fro reciprocating motion. Coming to the main parts of a reciprocating pump, it consists of a slider crank mechanism with a piston and cylinder, a suction pipe, a delivery pipe, a suction valve, and a delivery valve. Regarding the working of a reciprocating pump, as you can see, when the crank starts rotating, the piston executes a to and fro motion. As the piston moves from right to left, it creates a partial vacuum in the cylinder. Since the external pressure, which is the atmospheric pressure, is more than the pressure inside the cylinder, the liquid is forced in the suction pipe from the sump. This liquid opens the suction valve and enters the cylinder. Since the suction valve is a non-return valve, it will allow the water to flow in one direction only. In the second stroke, that is from left to right, the piston pressurizes the liquid inside the cylinder, which closes the suction valve and opens the delivery valve, and the liquid forced into the delivery pipe. Again, the delivery valve is also a non-return valve, which will allow the water to flow in one direction only. Hope that the explanation given above regarding the working of a reciprocating pump is fairly simple and easy to understand. Now, let's talk about the mathematical relations used in the calculations of a reciprocating pump. First one, the discharge through a reciprocating pump. What is shown here is the schematic representation of the reciprocating pump. Let capital D be the diameter of the cylinder, A be the cross-section area of the cylinder given by pi by 4 d square, small r be the radius of the crank, and capital N be the revolutions of this crank. Let capital L be the stroke of this piston, which is relationally 2 times r. 2 times the radius will give you the stroke. Hey, coronavirus, skip. Okay, HS is given as the height of the axis of the cylinder from water, surface and sump. This distance. Now HD is the height of the delivery outlet, which is this distance, and volume of the cylinder is given by area of the cylinder multiplied by its length. And if the number of revolutions is given as n by 60, the discharge capital Q is given as discharge in 1 revolution multiplied by number of revolutions per second, which is ALN by 60. Very important relation. And weight of water delivered per second is given by rho GQ multiplied by discharge, or as rho GALN by 60. Note down these 2 expressions which are very important in the further analysis. Now coming to work done by a reciprocating pump, the work done per second is given by weight of the water lifted per second, which was previously derived, multiplied by total height through which water is lifted. What is the total height? It is nothing but HS plus HT from the sump till the delivery section, which is W multiplied by HS plus HT, where HS plus HT is the total height. Therefore, capital W is given by rho G ALN by 60, and substituting the value, you will get the work done per second as rho GALN by 60 multiplied by height. Therefore, the power is given by work done per second divided by 1000. It's a factor given to convert the watt into kilowatt. And the final expression you have is rho G into ALN into HS plus HT divided by 1000 kilowatt. That's all.